Hello everyone, and welcome to F5 Demo Days, a program designed to make you familiar with the power of F5 distributed cloud solution. In these short demo sessions, we will show you how easy it is to enable SAS-based security services such as Web Application Firewall, API security, bot defense, and DDoS mitigation. I am Raffaele D'Albenzio, Manager of Solution Engineering, and I will be your host for today's session. Before we get started, just a few housekeeping items to note. If at any time through the session you experience issues with audio or slides, try to refresh or even restart your browser. Sometimes switching to a different browser may also result in a better experience. If you have any questions through the presentation, please submit them in the Q&A box. We will conduct a live Q&A session at the end to answer questions on today's topic. The topic for today's session is blocking automated threats and smart bots, and our presenter today is Patrick Zoller, Security Solution Architect at F5. Over to you, Patrick.
Aveli, thank you very much, and welcome to our today's session. Let's continue and start with the first slide. We're talking today about distributed cloud bot defense. While in the previous version and previous recording, we've been talking about how can we secure an application with Web Application Firewall, DDoS mitigation, enablement. Today, the pure focus is to mitigate malicious bots. And this with a sophisticated solution which collect behavioral signals to detect malicious access to your application. On top of that, I will show you how you can configure bot management your own way. What it means is there are multiple ways to configure bot mitigation capabilities on distributed cloud. The one which we show today is the fully integrated distributed cloud possibility. And let's continue. If we talk about bot defense, there are two flavors available on distributed cloud. One is based on signatures and collecting user behavior analysis. This is part of our WAAP offering. It is included, is there. It delivers good outcome, means good protection against automated traffic. However, to protect against sophisticated bot attacks, means attackers which are really working hard on getting access in an automated way to an application and doing, credential stuffing attacks. There is a solution which has been implemented, and that solution is collecting signals on the client, on client side, analyze them, and process them in real time. What it means is that we have a real-time capabilities to mitigate these automated attacks. And how are we doing that? XC Bot Defense mitigates bots in real time. This is what I said, on a wide variety of signals collection. And we collect also behavioral biometrics. And when we combine those signals, we have a chance to detect highly sophisticated attack. In fact, these are bots which look like a real human, but we are able to detect them by, as I said, collecting a lot of signals. And what are we doing is we're going through a multi-phase approach, means the way of how our signals collect data is in a multi-phase approach. So at the beginning we look, are the headers in the right order? Is the client able to execute JavaScript? What kind of payload is being used, and have we seen potentially the payload already? And does it look like human behavior, or is there some behavior which looks like automatically? And we asking all the questions in our signal collection up to a point where we definitely can say, well, this is a human or that is automation. In doing so, we have, we process roughly 4.5 billion HTTP transactions per day. And those transactions being enriched with data and updated through our research team. And what the research team is doing then, two things. A, they're working on unsupervised machine learning algorithm, which continuously monitor and process the data which we see, and feeding alerts into a system where a research team is, well, an expert is reviewing all the signals and all the alerts and building, a system which has low false positives. And those machine learning algorithms then go in a next stage where we push out a supervised machine learning model, which is again reviewed by a team of experts to reduce the amount of false positives. And this human in the loop making the system more accurate and scalable. Next slide. Here we are. And coming back to the demo, talking about the demo, in our previous versions, we deployed an app, and that app is the F5 XCDemo sentence app, which is available in Azure in the public cloud. This app has been exposed to different regional edge, one in Paris and one in Frankfurt, which makes the availability, it makes it global available. It makes it global available for legitimate user, but it makes it also available for attackers. With that, I'm going into the demo and share my screen. Just a second. Window. No, I don't see the window which I want to share. No, I can't share. Just sorry for that. So let me not showing me the right window to share. Okay, let me share my entire screen. Share. Raf, can you see my screen? Just to make sure. Okay. I hope you can see my screen. I'm sharing. So let's start the demo. It's a recorded demo of our sentence app. The sentence app is the app which we used in the past, and it has 4 items: an adjective, a pet, a color, and a location. And all these information of the adjectives are stored in a database. You see it here: kind, proud, calm. And what a user can do is he's able to add an additional adjective, like big. So he added through a form field. It's then part of the database. We fetch it, and it's in here as ID4. It's with name big. So let's see how the process behind the application is working. Adding a new adjective like tall is doing a post request to an endpoint, and that endpoint is API sentence adjective. Doing so and knowing that the request is working, an attacker is able to fetch and collect these requests and build a kind of automation around that by doing a stuffing attack. In our case, it is a stuffing attack against the application, a color stuffing attack. In real use case and real life, it would be potentially a credential stuffing attack. So when I say a color stuffing attack, I'm using the endpoint adjective to insert colors rather than adjectives like tall and big. What it means is we do not have any input validation. We do not detect without bot defense that this is an automation. And so we allow the automation to that endpoint. How does it look like? I'm using Postman runner. The adjectives being added to the application, refreshing the application means that I will now see a color rather than adjective. So in our case, it is apricot, for instance. So now back to the distributed cloud web UI. Within the distributed web UI, I have the possibility to configure the web app API protection for a specific domain, in our case, it's the sentence app domain. Going into the configuration, you will see that there are, and you know that UI from the previous version, where we already enabled the web application firewall to protect the application. In our scenario, now we will enable the bot defense. Enabling bot defense, we go into the configuration menu. We enable bot defense. And when bot defense is enabled, we select a region. And that region is the region EU, because we want to be, we want to be compliant. Compliant with EU regulation. Afterwards, I go into the deeper configuration where I have 3 configuration menus. A is the protected app endpoint, B, the JavaScript insertion. This is, and here I specified the path where we inject the JavaScript, which then collects the data which get been analyzed. I'm able to define where to insert the JavaScript, whether I have specific pages or I want to inject the JavaScript on all pages, and at which location I want to inject the JavaScript, whether after a head, after a title, or before a script. And for sure, beside the web use case, we have the possibility to detect and protect mobile devices with SDK configuration. And now going to the protected endpoint configuration. A protected endpoint is where we expect to have the analyzed results of the collected signals being pushed to, means in our case, it is the post to the /adjectives. This is the protected endpoint. This is where somebody is able to add additional well, it's a form field, yes, and we want to protect the post against that specific form field. And doing so is quite easy. We add a new item, we give it a name. The name is, in our case, protect pass adjective. The method is a post method that can be easily detected by opening the developer tool. The request method is post, and well, we select the method from the drop-down menu. Bot defense is also able to detect scraping attacks and other kind of attacks by selecting different methods. We have a domain matcher, but before we select for sure the protocol, in our case it's both protocols, HTTP and HTTPS. And if you like, and we do it here, we have an exact match on the domain. To figure out which domain we want to protect, going back to the developer tools, Chrome console, and copying over the host name to the configuration menu of XC bot defense. And now the path. Which path do we want to protect? At which path we want to attach our signals so the signals get been analyzed by our cloud instance? The path in that case is the API/sentence adjectives path. That path gets been copied over to the configuration menu. And yeah, done. And next step is define the channel. So is it web, is it mobile traffic, or is it web and mobile traffic? Selecting mobile or web and mobile is changing the further configuration menu. We stay with the web part and say that we want block mitigate, we want to block automation traffic, bot traffic. And we offer and want to provide another status code, rather a 200 OK, which is in as default. We select 302 found, and we change the response page to, well, today's XC demo day. That's all from the configuration perspective. We configure apply. We do a sanity check. Okay, name is there, method is there, the domain is there, path is there, the mitigation action is in, and well, it's web channel only. We apply the configuration, do it again, save and exit, and now it is there, and we're going back to our application and want to test whether it's working, because we want to check whether the configuration we done on our portal potentially broke or broke the application. Doing so, we do a refresh, And interestingly here is that you see that we now inject JavaScript. The JavaScript gets been injected from distributed cloud to analyze whether that is a legitimate user or whether that is potentially automation. And you see within the path section of the developer tools that a defined specific path where I want to inject the JavaScript tool. That can be customized to your application for sure as well. Me as a human, I'm still able to use the application. Within the form feed, I can add a new adjective, in our case long. Should work because I'm not a bot. What you see now here is the signals which we attach to the protected endpoints. Means in the first phase where my app/comment.js, we injected the JavaScript to collect the signals. We posted a specific adjective to an endpoint, and within that post, we attach our signals. And these signals get been analyzed by distributed cloud, and the result is, hey, this is a human or this is a bot. And within the dashboard, you directly see the outcome. 2 requests, 2 humans. It was a post against a specific path, and within the further information, you see that there is an area which tells you that the inside of bot defense is saying, well, it's a human and the action is allowed. Going further, I'm doing a manual request with Postman. I get a response code, a response from distributed cloud saying that I'm a bot. The reason for that is Postman in that case is not running the JavaScript. And going further, running an automation, a new automation, similar like the one which we've done before, automation to post colors to a path which expect adjectives. You will see that all these requests being blocked. So we run that against the endpoint. Endpoint is the same one. You see the error code is the 302. The response code, not the error code. The response code is a 302, the one which we defined in distributed cloud. Going now back to the portal, there are overall 29 transactions, where out of these 29 transactions, we have 27 malicious bot requests. You see the source IP, the AS number, the host, as well as the endpoint path. And the reason why we are blocking is we expect a token. A token in our terminology is the signals to the protected endpoint. Moving forward, there is the capability to go inside security events and check on further detail. Scrolling in and going down, what we will see is that moving. Yeah, no, it was not moving for some reason. Going down and drilling in further, what you will see is that there are some information about the automation type, token missing, and the action is blocked. That was the demo. Thank you very much for watching, and I hand over to Raf now.
Thanks a lot, Patrick, and thank everybody for joining. As I mentioned in the chat and in the beginning, you can send the questions in the Q&A chat. We already got some of them, so Patrick, I would ask you to be as short as you can, so we can answer the questions from everybody. Okay, let's start with the first one. The first one is the following: is the client classification, so bot or no bot, for any specific customer centralized, shared across the customer, or does every customer service have to do the classification from scratch?
Okay. No, well, it's a very good question. First of all, the classification of a client, it's basically we are not saying if enterprise A is using our technology or enterprise B is using our technology. We have an own classification behind it. What we are doing is we are checking JavaScript, which is per customer. It's customized. The obfuscation is customized, but the signal set, it's a signal set which been injected into the response to the client and analyzing the client capabilities. That is a generic one, I would say. It's not per customer. So we're collecting a lot of signals on a generic base. However, you have the possibilities, if you think that there is an automation ongoing which potentially not being detected, to speak with our support team to get an analyzation of the traffic pattern and potentially then to be able to inject additional JavaScript or data points, which then being collected and analyzed the traffic. What I mean by that is, it is shared. It is the same JavaScript we inject. It's obfuscated. However, it's changed on a regular base. Customers, if JavaScript for customer A is being compromised, it can't be compromised for customer B. Yeah, well, that is the answer to your question, I hope.
Okay, thanks a lot. Thanks a lot, Patrick. Second question, are the algorithms the same of those implemented in Advanced WAF bot defense as in the Big IP version 16, or they are different?
They are different. I was talking at the beginning about the way of how you can consume distributed cloud bot defense across various systems, and one capability and one possibility to consume distributed cloud bot defense on a Big IP is via a connector, which is the IAP connector, and that enable you to use bot defense on a Big IP, rather the unified bot protection. And so the signal connection is different between what we offer on Advanced WAF, on Big IP, and what we offer with distributed cloud bot defense. It's a different set. However, going forward with version 17.0, we have a native integration to consume distributed cloud bot defense on Big IP, and 17.1 and future version will have that as well.
So it's fair to say the AWA from version 16 can be even augmented with the bot defense that is coming from a F5 distributed cloud. Is that a fair assumption?
That is right. That is right. What we see in the field is that some customers use the signatures, which come with Advanced WAF, beside the distributed cloud bot defense offering. Though they're doing a full site protection with using signatures, however, high value endpoints like login pages, logout pages, and so on being protected by distributed cloud bot defense. That's right. Yes, it can be augmented.
Thank you, Patrick. Next question is every request from the same client and user processed by bot defense, or only the first one and the client is marked as allowed or as bot?
No, it's every
Are we processing only the first request or multiple of them?
No, so it is not on per request, it is on per protected endpoint. And if you, for instance, have a /login path, which is defined as protected endpoint, and the client is accessing the login form, submitting his username and password, the system is analyzing whether it's a human or automation, and then if the credentials are valid, you will have access to your banking account, for instance. Then we do not analyze the request again, because we checked it at the gate, at the beginning, at the login path. We validated already that it is a human rather than automation. However, if there is an automation ongoing, and this automation is doing a credential stuffing attack against a protected endpoint, we analyze each and every request, and that in real time. Real time means for sure there is a connectivity to an endpoint, and that has it requires some time to get analyzed, but we are in milliseconds range here. So there is a short impact on processing, but I think it is roughly 50 milliseconds for a login, which is acceptable.
Okay. Next question is about web and mobile access. So how are the web and mobile channels differentiated, and why it would make sense to have a different bot mitigation settings applied to them? I'm assuming mobile, I mean apps in this case.
Yeah, I think the question is can you repeat it again? Sorry, I didn't get it completely.
The question is, how are the web and mobile channels differentiated? When mobile, I'm assuming they mean the native application. And why would it make sense, I would say if and why, it would make sense to have different bot mitigation settings applied to them?
Okay. So first of all, when we talk about mobile integration, we offer our SDK. And within the SDK, you can set some attributes, some header attributes to distinguish between web and mobile if you run the service on the same load balancer instance. So there is a differentiator based on header information. This is available in the portal to configure, and why it makes sense to distinguish between, I think, whether allowing or blocking or having different mitigation capabilities. Well, I would think either there are mitigation capabilities which standard native mobile devices can't work with. So with a web client, there are capabilities to, for instance, block, drop, or potentially redirect it to some other destination where native integration or native SDKs do not supporting it. So there are other mitigation capabilities necessary to configure.
Okay. Thank you. Another question, which is a little bit less technical. Do we need to have a specific license on the F5 Distributed Cloud to deploy the WAF service? And is there any way to test the bot defense in like a trial edition? So is there any possibility to have a trial access to the bot defense solution for the customers?
Yeah, that is possible. If you want to test it, reach out to your account manager, to your F5 contact. We are able to onboard you as customer, as partner, to a trial license. That is possible, definitely. And when it comes to the pricing model, the pricing model behind bot defense is per request, means API request. So how often per month is getting the API fetched, means how many transactions do you normally have against your, in our case, against your login form. And for each request, we're fetching the API overall per month. That is, for instance, 10 million requests. And for that, there is a pricing model available.
Okay.
So we got customers for 10 million requests and above.
Okay. Another question is about traffic control. So can we control how much traffic that is supposed to come to our website or the application? I'm assuming they refer to like limiting the number of requests or trying to, let's say, to read the question in a different way. Can we control the number of requests per second that can be applied, say, to the specific website?
I think, okay. I think the overall goal of distributed cloud bot defense is to take the automation. When the question been asked, can we limit the amount of requests per second on an application? I would think it is about automation traffic, rather valid traffic, because having a lot of valid requests from users on a page is good, I would say, because it generates business. And so I think it is about automated traffic. The overall idea behind bot defense is to detect that automation and then react on it. Means if we see that request been automated, we try to block it, redirect it, drop the request, whatever you want, whatever you configure as mitigation option. So yes, there is a chance to react on that traffic, but steering the traffic or reducing the amount of traffic, I think that is something which we can achieve in combination with DOS mitigation capabilities. So I think that session happened last week with Sven Müller. He was talking about DDoS detection and mitigation. A combination out of bot defense and DDoS mitigation potentially is helping you to reduce the amount of traffic you see on your application when it is about automated or unwanted traffic. Not talking about legitimate traffic.
Okay, we are already over time, so let's do the last one, and then for the others, we will for the other questions that we didn't answer, we will contact you directly to try to answer your question. So the last question is how much we are using, if we are using our, let's say, Shape security technology, and what we developed on the device ID on this solution. If and how, I would say.
Okay. This is an expert, a partner or customer who knows that we acquired Shape a couple of years ago, and we had offerings like Shape Enterprise Defense, that was a fully managed service approach, and also Silverline Shape Defense, which was the solution which been available on our Silverline offerings. To give you some insight, over the last 1.5 years, we've been thinking about how to offer a really sophisticated and really cool technology across a wider set of platforms. So the development of integrated bot defense was started, which allows our customer consume Shape technologies via different form factors, like consuming bot mitigation capabilities on Nginx, on BigIP, in distributed cloud, on other technologies with other connectors. And going back to your question, there are different models which we use on distributed cloud coming from Shape Enterprise Defense. So it is not a complete new technology and new development. It is the way of how the Shape technology is being consumed across multiple offerings. In our case, and that is what we cover today, on distributed cloud, there is a chance to consume the Shape technology by an integrated connector, and the secret source behind it coming from Shape. That is right. The connector is a different one, and it's not a fully managed service. It's a SaaS offering, which you consume from distributed cloud. Device ID is not in there, and yeah, that is hopefully answering the question.
Thank you, Patrick. Yeah, you were shorter than I expected, so there is time to a very quick answer to the last one. One question is asking, you are collecting metadata from a client, okay, and you are processing them in an environment which is cloud-based. Is this, let's say, compliant to the regulations we have today, or?
The question which we get quite often, to be frank, and it's a valid question, because the processing of the data needs to be compliant. If you, and it doesn't matter whether you live in the EU or in APCJ or in US. Sure, there are different laws and regulations, but however, it needs to be compliant for us in the EU with GDPR. And the answer is yes, we are GDPR compliant. There are information on our F5 webpage, on the main webpage, on how we are achieving that. And while I was configuring distributed cloud, you saw that there was an ability to select either a US, an Asia, or an EU endpoint. By selecting this endpoint, you decide where we process and store our data. For you, it is in the EU, and so we are compliant. We have our own team managing the compliancy, If there are questions, reach out to us and we can help you to find the right information if customers are asking that question, whether the technology we offer on distributed cloud is compliant.
Thank you, Patrick. Okay, we ran out of time, so I would say that that's all for today, for the time we had today. So for any question, as I was mentioning before, we didn't get to, you will be contacted directly. And with that, we conclude this session of F5 Demo Days. We would like to thank you for joining us today. And obviously, I would like to thank Patrick for the insightful demo and for answering your questions. Look out for an email for us with a link to the recording of today's session. And we look forward to seeing you again in our next Demo Day sessions. If you haven't already, please take a moment to complete the brief survey, which will also pop up when the session ends. Thanks again for being with us today, and see you next time. Thank you.
Thank you.